Good afternoon, everybody. My name's Stephen Frenneman. I see people are still joining. I think we'll start so long. Just to welcome you all at the third webinar that we are presenting. This time we are discussing specialized antennas for IoT. And presenting we have Dr. Andre Fourie, who is the CEO of Poynting Group. And Andre, I hand over to you.
Hi everyone, very nice to speak to many of the interested people, many of our customers. I'm just going to try, I always hate displaying my own face, but just so you at least see that I'm live and not just recording. We're going to discuss IoT, but I'm not trying to give at all a lecture on IoT. We're really looking at IoT in relation to some of the specialized antenna requirements and going to discuss a few very interesting cases. So it is more casual. We've chosen case studies that we found very interesting results, and I'm sure you'll enjoy sharing some of it. Not all of them that relevant to people in a certain part of the world, but I think will be very interesting. I'm going to switch off the webcam. And at any time, I think you can push the chat box and indicate if there's questions in between, and I can stop and answer some of them. I've gone on mute. So that's the agenda, but let's just move into it. We're trying to make these sessions a little bit more, sorry, I've just got my big picture. The big picture with IoT and machine-to-machines is in fact that we've got IoT has existed for all the time. We just sort of suddenly doing it and calling it IoT, and people are calling it the fourth industrial revolution and so forth. But of course, it's been done. People have been controlling things, and here's the sort of technologies that's been used, traditional ones, and then lately there's some very specific ones, and IoT has of course grabbed everyone's attention. So if you look at it, this overview I'll leave for you later. We'll send you the webinar. I certainly don't intend to go through them, but these are all those technologies. The real point I want to make is that antennas don't care about the technology. People often ask us, is this a LoRa antenna, or questions like that. They don't care. What is very important with antennas is the frequency. They'll transmit anything. They don't care what the protocol is. And of course, the actual performance. So you have to select the right antenna for what you wish to do. What we're going to do is, I'm just going to look in detail at some of the very specific and perhaps new IoT technologies. These are LoRa, Sigfox, the new narrowband LTE techniques or specific modes, Wi-Fi. I think Wi-Fi is still very important. And then mesh. Mesh is becoming a very, very interesting technology, and we've had quite a bit to do it. Often the mesh still using the Wi-Fi frequency ranges. Now, if we go over to them, they're quite different in many ways. The Sigfox LoRa guys typically sit at well, in Europe, they sit at the 868 band, America, the 915, the so-called ISM bands. LoRa, certainly going up to kilobits per second. You can define it a little bit more because that's controlled by the guy that puts the network up. Sigfox is an international network, and that works at very low data rates, but extremely good sensitivity and very long distances, also very difficult to jam and to stop, and the devices are quite low cost. Then, of course, as you go to GSM, you can go to kilobits per second, typical the IoT bands, but you can go all the way up to megabits per second speeds. These ones, of course, can go up to high megabits, the Wi-Fi technologies. Mobility, you can have a look at that. It sort of depends what you consider to be mobility. Coverage is very important. People say LoRa, Sigfox, like they do technologies that just compete. They're entirely different in the sense that the LoRa network is put up by typically the company or sometimes an operator, where Sigfox is an international network. So you can't put up a Sigfox network, you can't put up base stations, whereas LoRa is much more under your control. But of course, this is national, international in many countries. I call the LTE ones national because for IoT, people are not going to use roaming. It just doesn't make much sense. And of course, Wi-Fi is very small sort of coverage, and mesh somewhere in between can be as large as you create your own mesh. There's the ownership. I think I've gone through that. If you go to client device cost, that's an important factor. Typically, LoRa, Sigfox very low. These ones, what we call medium, and most probably the mesh ones higher. Not because it's because mesh doesn't have a client. They're all clients and base stations if it's a true mesh network. Data subscription cost is an important factor. That's where, for example, LoRa and these differ because these are put together by the users. So the actual data cost is nothing. Sigfox typically very low. And of course, these could go medium to high if you look at this range of costs we're talking about. The network deployment cost, once again, if it's operators, doesn't cost you anything. LoRa, you have to deploy yourself. Call it medium, low cost for Wi-Fi. And this one is higher just because every device there is actually quite an intelligent device. So it costs quite a bit because the network is in fact all of the customers and could have sort of base station nodes, but they're exactly the same thing. Battery life is a very, very important thing. And we've defined it long, very long, medium. I'm saying short. And I am aware that there's now Wi-Fi guys doing some very clever low power Wi-Fi things, but generally speaking, that's the case. LoRa, and these are very rough parameters. Of course, antennas feature a lot here, but say in a rough range of order of 10 kilometers, Sigfox very large. And the GSM or narrowband LTE IoT, it differs, but it goes up to 50 kilometers. This certainly just in order of hundreds of meters. And here depends how big your mesh ultimately is. Okay, we're now just going to look at Omni performance. This is what I mean by just touching on some of the very interesting aspects. Clearly, because IoT is often devices that could move, they client devices. You would like to have a, sorry, I've just got an earphone dropping. You could have, you need omnidirectional antennas, and omnidirectional antennas has been one of the biggest pains in my life. Some of the people in Europe I've given a talk to, but what we sit with is omnidirectional antenna. In a guy's mind, Omni is not defined by any standard, but we assume it's round. You know, it radiates equally well in all directions. Gain, on the other hand, which is one of the parameters people look at, you know, very much like they look at kilowatts in a car, is actually relevant specification for Omni antennas. The reason for that is actually extremely simple. Gain is defined as the one point in the radiation pattern. There you see the whole bubble of a pattern. It's defined as that one point where the maximum radiation occurs. Now, clearly, if you think about one point in omnidirectional, you can see why I say it's a meaningless parameter, because in an Omni antenna, we don't want to know what it does at one point. We want to know what it does in the directions we wish to communicate in. So this is one of the things we had. We said people, there was a certain antenna, a competitor antenna, people say, that one is quoted as 2 dBi max. Our puck antenna, in this case, is quoted in the same frequencies as -1. Bad problem, eh? If you suddenly realize that someone's outperforming you by 3 dBs. And then we looked at, and these are not our measurements, this is actually the information provided by the competitor. So he's actually extremely honest about it. He does what the spec allows him to. He chooses the maximum radiation at that point, that is 2 dBi. But note that this is a bubble, so you actually, this is towards the horizon, these points around here. You can see the hot spot here is going about 30 degrees upwards, so that's most probably somewhere to the moon, and this may be Venus. But if you look at the radiation in the sideways direction, it sits at this green point here. That's -6 dB. Now, if you look at a puck, for example, you can see the -1 that we've got is actually going towards the horizon, it's going everywhere. So in real life, in terms of usage of this antenna, this guy's going to be -6, this guy's going to be -1, changing the whole perspective. So we cannot look at gain. You actually have to look at the pattern. Is the pattern doing what you would like it to do? Now, the one thing that is quite laughable is the fact that Omni is not defined. The next example shows this. We're still looking at a competitor Omni antenna. on this side. This is now also just an azimuth plot. In this case, it's again got a little bit more gain if you look at these two spec sheet values here. But look at this, you know, the first thing I would say, it's a rather brave thing to call this an Omni antenna. This is the radiation going sort of 360 degrees. If that's north, that would be, I think, west and south and east, okay? And you can see that, once again, this guy quite legally and validly said that that's my gain, because the gain is only at one point. There it is 5 dB. But note here, it's 14 dB less. In other words, and many other parts of this spectrum, it is much below 0 dBi. Once again, if you look at our antenna, it is lower in spec, but you can see that you're actually getting something that's going to be 1 to 3 dBs instead of minus 14 to 5. And I think it is crucial. People say to me it's difficult. Just ignore the gain. I say bigger the gain, the worse the antenna, because an antenna is like a balloon. If you squash it, and the guys clearly squashed this pattern here, then yes, it bubbles out to other sides. Okay. So the only way to get high gain on an Omni antenna is to mess up the design, bluntly speaking, unless you've got a long antenna. But if it's short, you can't push it from the top to make it bulge out, which you can do on a longer antenna. But you can push it on the sides, and that messes it up for everyone, because how do you know where your base station is going to be? So crucially important to actually look at Omni patterns, and not wanting to boast. If you don't want to sit and analyze patterns, work with a company that's designed something that should be working, because we certainly would not mess up an antenna in order to have one specification look good. And typically antennas have got very good omnidirectional patterns. Why are expensive antennas often cheaper? There's a whole business case here, and I'm not going to go through it in detail. The principle is very simple. I say to people, and this is often a bit shocking to them, that in 80, sometimes 90% of cases, an absolute useless antenna will perform the same as a very well-designed pointing antenna. Now people say to me, if 80 or 90% of bad antennas is as good as a good one, then why the hell should I pay 3 or 4 times more for a well-designed antenna? The real answer is there. If you've got, for example, with tracking, we've got guys that's got 50 to 100,000 vehicles out on the road. Say we use 100,000, and 10% of them don't perform well. That's 10,000 vehicles that you have to go refit. 10,000 customers that's most probably not happy. And you may find a good antenna would give you good performance in 98% of the cases. So what I'm always saying, that's why field tests are also pretty meaningless, because like I say, 80 to 90%, you're going to see another antenna doing pretty much the same as our antenna. But 90% is not nearly good enough, and the costs of actually going to fix it, just the direct costs, whether that's credit card machines or anything else, is much larger than the saving that you make by buying a cheaper antenna. That's the direct cost. Just please consider that we design IoT systems not because of the mounting and things like that. We do stuff with them, you know, we process credit card payments, we track cars, and what is the cost associated with that not working? In other words, the main overall system cost is another factor that's not even sitting in here. So I really encourage people, that's often the lowest cost item in the system. But as I've said before, if you look at the standards, there's absolutely nothing a guy can do with a modem to get a better link. These things are governed by standards. The only thing that can make a difference to the system you provide from a link perspective, I'm not talking about the fancy interfaces, protocols, error correction, I'm talking whether the link works or not, is the antenna. A modem cannot make a better link because it is governed by international specifications. So your only difference is actually your antenna. Why would you actually sit and skimp on that in terms of links? Now I'm going to application examples and case studies. And for example, I'm focusing a bit on mine antennas, mine and tunnel antennas, just because we've got some interesting results. And I think this is virtually the first time some of this has been published. Very difficult to get information on it. So please stick with me. I think they're interesting, whether you are going to use specifically those antennas or not. If you look at mine antennas, we started developing these guys actually 20 years ago. Then we dropped them as antennas because no one bought them. And then IoT became important. And suddenly they're buying it for all kinds of cases. You get linear antennas, Yagis and so forth. And
there's some information, if you can just scroll on.
Okay, sorry. Aha, I've got Stephen reminding me that I've got some pop-ups. So if you look at the linear antenna, and there's measured results that I can share with people if they're interested. After about 200-300 meters, the horizontal component and vertical component is equal. In other words, they rotate unpredictably as they travel down a tunnel. We've seen massive improvements by using circular polarization, because of course the polarization rotates. So if the one propagates better, then that one is the one that propagates. It adapts better with internal dimensions. If you go past obstacles, you find that one polarization often is more successful than another. So in many respects, also the first reflection of a circularly polarized wave do not interfere with itself. They are a tremendous improvement, and I say tremendous, and I'll show you some of the results we've seen. If you look at the tunnels and the frequencies, tunnel propagation is really difficult to predict, and we are trying at the moment to get some theory together, but it depends very much on this dimension, the size of the tunnel, and also crucially on the roughness of the tunnel. So we've seen some results, and I'll show them to you, where 5 gigahertz does extremely well. But 5 gigahertz, because every time you reflect, some of the energy is scattered. So as the frequency is higher, they scatter more. So at the for very rough antennas, the lower frequencies often do a lot better. You can see the type of antennas. We started live, and certainly we've covered about, I think we've worked out about 50,000 kilometers. Is that right? Underground tunnels. 5,000, I think is the figure, 5,000 kilometers roughly, using these antennas, all at 2.4. So a lot of our experience were gained here, just because Wi-Fi operates there, and people often used pretty simple 2.4 gigs. We're now seeing requests for both LoRa frequencies and LTE, so we've developed Healy antennas for all of those applications. And recently we've done some work with Rednet, which does a very clever mesh system that operates both at 5 and 2.4, and actually massive advantages. We show you some of these results. So we operate at both frequencies, and obviously then you get an additional benefit in that those frequencies are also not the same in propagation, and your chances are much better. We also now developing a new version of antenna that will cover everything from here to here. So it will cover frequencies up to 5 and including the 3.4 to 3.8 gig band. This is a nice test there. It just shows some of the tunnels. This was a platinum mine. And these are the results, like I say, that it's almost impossible to get hold. Everyone seems to keep them secret, but we've been able to get some of these results. And you can see this is a Healy to a handheld device, tablet phone. And you can see that we get good results in a platinum mine. That's not very big tunnels, up to about 155 meters. 200 meters still exceptionally good. I mean, I think all of you can see that a signal value of minus 30 dBm is massive, still a massive signal to noise ratio. If you carry on, sorry, on the left-hand side is the actual received signal, and on the right-hand side is the actual data throughput. So I apologize. That's the signal curve over there. Could never be that good, but it's still minus 60, whereas you can still communicate down to minus 80 to 90. This is the throughput. Massive throughputs, if you look at the technology, 80 megabits per second. And we've taken it in this specific mine on a Healy to Healy up approximately 300 meters. And you can see still with extremely acceptable levels. Also note this is 2.4, that's 5.8. So in the platinum mine, the 5.8 actually outdid it. We just couldn't use 5 in these tests here. And the ping speeds, by the way, is down to about 3-4 milliseconds, which is certainly 5G type of rates, which you can use to actually drive vehicles and things like that, although they're not yet doing that in mines. Here's a coal mine results. Again, using the Rednet mesh nodes. They're very useful because they just create their own network and adapt. Here you can see we got much better results again at 2.4 gigs. Since I use both, so these antennas are equipped, there's actually two 5 gigs and two 2.4, and it goes both directions. A really advanced antenna that we've developed for use with Rajant. And you can see these are completely different distances. Here we're going up to 700 meters and up to a kilometer. And you can see even up to a kilometer, we were still achieving 20-25 megabits per second rates with very acceptable ping speeds. So massive ranges that can be achieved with Heli antennas. Just as an example, some of these mines had normal Cisco radios in with little stubbies on, and there they used one every 50 meters in order to cover a tunnel. So you can imagine this is a really dramatic difference that these antennas make to underground coverage. And of course, we're very interested in starting to use them in tunnels, but that's not yet happened. They should perform as well there. This is an interesting case where there's a stoping area for those people not familiar with mining. This is where the guys actually actively mine. This is an interesting one because it's only 1.5 meter high. Stephen, that you listened to a while earlier, had to go in there and you have to actually work bent. This is why you have to get machines in there. I thought this must be the worst thing on earth to work bent down for a whole day. Here we couldn't fit the access point, so we fired into this very narrow opening. It's about 1.5 meter by 1.5 meter. And here's test points that we measured signal strength at. And it's a fair area. It's about 100 by 100 meter. And you can see over all of these distances, once again, got pretty good results, because here you've got these little supports. And once again, the circular gives you just huge advantages in terms of finding its way through all of, call it this mesh that it has to go through. Point of sale is one of the other famous examples. This is one of the examples where our typical competitors look like this, and they cost very little. Now, in many cases, this guy works, and I have to keep on emphasizing these field test problems. This guy works at some frequencies, so you may be able to do some testing. You may even find some frequencies that works better than this guy. But the problem is that if you start using them at 1,000 or 10,000 different places, you're going to find the operator uses different frequencies. Frequencies in the future may start differing, and you may have just been lucky because this pattern most probably moves up and down, and you could be lucky and it's at the moment down where you test it. You can't determine frequencies when you do field tests. It's normally done by the base station. So this is one of our antennas that's gained real popularity in South Africa. Virtually all credit card machines went over to this antenna from this guy. And in each case, it took 4 or 5 months of showing them results, trying it out in the field. My little example where they started realizing that 98 is better than 90% success. They've also been applied with ATMs. Here you can see the little stubby at the top. This guy here is a proper outdoor antenna, so it's not shown, because where they've then got problems, they can go outdoor and use a decent high gain outdoor antenna. And this is our vending machines. Once again, this is what I sort of say. I look at the direct cost of go refitting, but if this guy's losing money because his vending machine runs empty, that's a cost that most probably could be much larger than the refitting cost. Another nice and interesting case. This is just the guy, author, that said, can we help him? He struggles. He travels around in a RV or motorhome, and we fitted him with a MIMO 1 antenna. And he sent us various pictures like this, but this guy is really one of our best adverts, because he keeps on getting these type of results instead of these. And of course, many cases, you wouldn't even normally get a result. So beautiful results. Once again, making the point that going out and having a decent antenna really makes a difference, especially if you're in areas like we travels around. Oops. This is one of my favorite cases. I'm not sure whether we've got the guys on here, but I sat at supper talking to them. This is in a fjord somewhere in Norway, and there's an electric boat, and they would not allow the boat. It travels a long distance, and it's a massive sort of I suppose everyone knows what a fjord looks like. But unless they had communication, they wouldn't allow the electric boat to go. And this is one of the real extreme examples, and I love it, where there's four high gain antennas on either side, linked to 4 radios, okay, in MIMO mode. And that was the only way, and they actually get communications all the way through. And being a typical antenna guy, Harvard actually showed me photographs, and you could see his wife screaming at him because all he was photographing all the time was the antennas while she was enjoying the scenery. So vehicle tracking. In vehicle tracking, we sell tens and tens of thousands. And vehicle tracking is in South Africa a big thing because people steal them a lot. But it's also for fleet management. And it's the fleet management guys that first adopted decent antennas. Believe it or not, the first guys just stripped a piece of coax. And like I say, 80% of the time, most probably it worked. But they realized to refit the vehicles is a big hassle. And we designed one that you can just chuck in somewhere, and it's designed with spacing away from metal, so it works in most cases. And our newest version is called the Omni 510, and that's certainly a pretty new product. It's a very nice product if you just want to call it stuff it in somewhere, but you can also double-side tape it, and it's got 2 holes for screws. You can neatly mount it on a box or case or anything like that, but you can also just, bluntly speaking, throw it in with your electronics or hide it between the, what do you call it, the stuff in a vehicle, or in a bumper or anything such as those. Now a bit of the advertising. We always have to do a bit of advertising, but it's really just showing you the antennas we've specifically developed for IoT applications, and where I think we had an antenna which you could just put down. It had magnets on it, which was called the Omni 39. We now got this 280, and it's firstly a whole different kettle of fish in terms of frequencies, just covers about everything that you can use. And this is the big difference, because even if they're not using this now, they may start using this in 9 months' time, and very likely will. And you need an antenna that would work then. You don't want to go replace, again, 5 or 10,000 antennas because the operators start using different frequencies. This one's also just been much more universal in the sense that it's got magnets, it's got a mount, you can put it against the wall, against a pole, so it's designed for pole mounting, and magnetic, virtually every possible form that such an antenna would be mounted in. This is the Expo 1. This is an omnidirectional antenna, even though it doesn't look so omnidirectional. This antenna, again, covers a lot of the frequency ranges. We will extend it to more because it's everyone's demands. Beautiful because you don't have to direct it. You can put it against the window, you can put it against the wall, on a pole, and all of those different modes. It's our best seller. So at this stage, this is our highest selling antenna. This would be a different application for metering. So this is the Dash 1. There you can see it sort of fitting on top of a meter. People were putting the antennas inside. Now, not sure where these guys went to university, but that's called a Faraday cage. Stuff doesn't get out there. So in this case, that works a lot better. It's got a little mount so that it can neatly interface to the electronics on the inside. And of course covers all of these frequency ranges. I think I've spoken about this guy. That's just showing a few different mounting options for it. I'm not going to spend too much time. We are trying to keep our webinars shorter so that we hopefully can do it a little bit more regular. So anyone interested can ask afterwards, or of course can also look at the whole presentation. This is fantastic antenna. I was laughing. There's a company in the US that was actually advertising our antenna. And I looked at their video on YouTube and I discovered things about the antenna I didn't know myself. But this guy could be mounted in about 105 different ways. So it's got a removable spigot. It's got 2 different length spigots. It comes with adapters on the cables. It can go up to 5 in one, but we design it in various formats. It's certainly the highest performance vehicle mount type of antenna that we've got. Magnets, double-sided tape, sideways exit of all 5 cables. All can go out to the bottom. You could screw it down. There's screw holes provided. It is good, waterproof, rugged, It's been accepted by one of the biggest motor manufacturers in the US, where they're now standard fitted. I don't think we're allowed to say it yet, but if you go to YouTube, you'll actually see that there's other people that will tell you about it because they're resellers for this company. It covers anything, including the 400 meg band, which I think is getting popular in parts of Europe for LTE as well, but sometimes for other type of applications. And it can be configured in different ways. We've done one, I think at the moment, it's a 7-in-1. In other words, that for some modems, which has got 2 MIMO LTE modules built inside. So we're quite proud of this new baby. The puck range of antennas, once again, I'm not going to run through all the mounting. Pretty similar range of mountings to the ones that I just mentioned for the MIMO 3 antenna. But once again, if you go compare its performance, and please do, the actual performance, like I showed you in some of those slides, I think there's very little that beats it in terms of performance. But you'll also go online, you'll see that we exposed it to 30 kilovolts and I can't remember, 200 or something kilometer an hour winds, and drove a Jeep over it and hit it with a big piece of steel. It is one of the most rugged antennas, I think, on the market. This is the Healy range. This is the old range, if I can call it that. This is the stuff we've sold that literally thousands, most probably tens of thousands of, and which became very popular in the last year and a half to two. And this is some of the new antennas we hope to release this year. This one is virtually released. This Healy 5 is the one that will do the LTE range. This one here, although it's been used already a lot, is not formally released. It was designed specifically for some customers, but it will be released. And we're putting new Expo models out there, which will cover all of the 5G bands as well. And this one excites us a lot. We'll release more information, but that's not a new Expo 2 that only covers these bands. We're using some very advanced new antenna design technologies, and we're in fact improving this Expo 2 in its current bands by about 2 to 3 dB, which is incredible. So we call it, it's going to be the 5G killer antenna. That's the LoRa roadmap. We are going to do all of these antennas, or many of them that you're familiar with, but we're going to do them where they specifically optimized for these bands. It is a lot more effective because at the moment they're doing the LTE, which goes from DC to light, and there's compromises involved. We believe if we do some custom ones in this range will come out soon, Q4 or Q1 2020. I think that would be an excellent solution because they would do a lot better in that frequency band. They don't need broadbandedness because those standards are very well defined for those frequency bands. I hope that covered a number of interesting topics on some of the new products, some of the problems, and some of the things one should consider. I'm not sure, Stephen, whether there's any questions that's coming through.
Thank you, Andre, for that. Can you hear me, by the way, Andre? Okay, good. So just looking at the questions, I don't see any specific questions. Somebody commented about the sound level. Apologies for that. If there's any other questions, you're very welcome to post them here. Also, you're welcome to go afterwards. You'll also see that within this webinar, we've got an email address, which is webinar@poynting.tech or info@poynting.tech, and you can pose any questions you like over here. If you need more information about the antennas that we've just spoken about, you're also very welcome. And thank you for joining us. Sorry, I've got another question here. Will the new Expo 2 still be called the Expo 2? So, very good question. So we haven't actually released this new antenna yet, but we plan to call it the Expo 2 5G. So when we refer to the Expo 2 5G, in the part number, it will be Expo 2 as per the previous part number, but it will, instead of having the V2, it will be the V3. So this will be our third version of this antenna, and We will actually have a full release on this antenna in the next month or so, and we'll also have some videos comparing, just for interest's sake, our very first model of the Expo 2, our second one, which is current and which we still plan to supply for the next while, and then also the third version, which we plan to release. And we'll even be opening up our antennas and showing you what's inside. Quite interesting how the antenna has evolved and become more, let's say, technology driven. And we'll also be showing you at that time comparing the, let's say, the very first version that we had. And we have a lot of competition that are actually selling the similar antennas to the very first version that we had a long time ago. Although we're sitting at version 2, which is newer than what they have, but we are moving to version 3 now, which is 2 steps ahead of our competition. Actually, in many cases, I'm not sure if every single competitor of ours is at that level or not, but at least it's some food for thought. But we will present that when we are ready to release that antenna, as I said, which will be in the next weeks, maybe the next month. So, but we will send out communication to everybody on that. It appears as if I may have another question. Yeah, I just can't find it at the moment. It popped up on my screen. Are 3D patterns available for all your antennas? Yes, they are. So please just contact your sales representative and we would be able to give you all of those patterns that you require. Some of our older antennas, we may not have them ready and there might be a slight little lead time to be able to provide them to you, but we definitely do have. Sure, I see a lot of questions that have arrived over here. Will your presentation be made available to us? Yes, definitely it will. And we'll follow up this webinar with a link or with the details where you can download the presentation. It will be in a PDF, and we will also on YouTube and LinkedIn present the or give you a recorded video. We'll also have a newsletter very soon, and the details will also be in there. So if you're not on our newsletter, by the way, please do subscribe. Just send us an email at info@poynting.tech, as you see on the screen at the moment, and we'll send that through to you. Okay, another question over here. Will the presentation be available? Yes, as I've just mentioned. Are the antennas used in fuel storage? No spark to cause explosions? Yes. So we must, maybe that is just another thing that you can contact your sales counterpart on. We do have a number of antennas, especially in the mining side, where we have intrinsically safe, which is specially designed and specially coated so that if there are any sparks, or rather, not if there are any sparks, just that the antenna does not create any combustion or explosion as a result of the RF and building up of static electricity. If you have any further questions, you're still welcome to email us and we'll give you a little bit more details. Do you have any examples of applications that use LoRa? Andre, I don't know if you want to answer that, but we see quite a lot of especially sensors, whether it is in tunnels, mining tunnels. We also see in transportation. We also, Andre just mentioned elephants. So Andre was responsible or involved in a project. We were tracking elephants in our national parks, and we used LoRa for that. LoRa is also used for possibly smart meters and things like that. So yes, LoRa is used quite widely and quite often. Okay, Andre just mentioned that LoRa is still growing, and we see more and more applications coming up for LoRa at the moment. So maybe not that new, but as Andre said, it's still in the growing phase and actually relatively new. Any other questions over here? I don't think so. It seems like all. Hang on. Oh, yes. So just a comment from Frank, who's our GM for the South African business unit. And he just mentioned that GRW, a subsidiary of PSG, uses the Omni 232, which is the forerunner of the puck antenna, which we showed you earlier, on all fuel tankers. Explosive testing was done over the last 12 months before accepting it to be used on their tankers. So just for information over there, the puck antenna is actually the newer version of that specific antenna, and but the specific company prefers to still use the old antenna, and we're still manufacturing the old antenna for them. But all the same characteristics are carried over to the new antenna, just the performance has improved, and that we have additional mounting options and so on for this new antenna of ours. Good, and then I think I'm going to close this. Although we're sitting at 44 minutes now, we actually plan to do it in 30, but the questions, let's say, are somehow forgiving on the time. And if you have any further questions, as I mentioned, please do contact us, webinar@poynting.tech regarding the webinar itself, or info@poynting.tech if you need any additional information. Thank you very much, and hope you enjoy your day.